Hi, my name is Ryan Wilkins, and tonight I will be presenting on technology adoption in conjunction with technology reuse when developing new products. This isn't going to focus on the traditional technology adoption by users or by customers, but more the technology adoption of a company when developing new products. An example would be the advanced driver assistance systems that a lot of automotive companies are implementing into their vehicles today, like adaptive cruise control or lane keep assist, things like that, where there are new technologies that might be developed by the suppliers, but they have an R&D organization that they invest in that proves out these technologies and helps when integrating them into new products. On the agenda, we have an introduction where I'll go through the problem space and then also show some of my sources that I found. I'll go through the model description, some of the references that I was able to find for my model, and then also the reference modes. And then finally my results along with the verification and validation against, or from what I could do against the reference modes and the reference charts that I had. So to start with, there's an increase in software and electronics and new products. It's becoming easier to quickly produce technology variants, and this will cause an increase in the product complexity, but also provides great opportunities for companies who understand how to streamline the process of evaluating, developing, and integrating new technologies. So for the overall problem space, there's a number of inputs that goes into defining the optimal reuse for the new products. When starting a new product development program, it's critical to define the right program product scope. And one piece of this scope is optimal amount of technology reuse, and how do you leverage that from the existing products. These questions are focused on getting new technologies in the hands of the target customers while still keeping costs low enough to get a good ROI on these new products. This picture is a reference from a guest lecture that I had at the start of my master's degree at CSU, where we had a guest from Wolf Robotics, who I think is local to the Fort Collins area, came in and just presented on system engineering in their company, what it meant to them, and how it really impacted their R&D as much as their new products. And what this is showing is that generally what they shot for was 80% standard parts and technology, and that left the design engineers a remaining 20% to focus on the new technologies. This is a good practice in managing the overall project risk with respect to the program product scope. First, the marketing and product managers are focused on the standard bell curve for technology adoption by the customers. But as they get more adopters of the new product, they want their market share to increase, and that's what's kind of indicated by the yellow curve. It's also important to make sure you get the right technologies out there in the hands of the early adopters, but also only releasing features to the market that are mature within the organization's R&D process. This is what's shown on the right-hand side. The chart actually reads right to left, but you can see that you have a number of technologies that are over, they were in the labs, emerging from labs, and then they start to move to the left. And then as they mature, you want to integrate these into new products. And then as you reach economy of scale for these, you will start to increase their exposure in the new products. This is kind of a product platform strategy. And then also from a product management standpoint, you want to make sure that you stagger your projects, and also stagger your products so you can maximize reuse and also maximize the profits across the product portfolio. That's what's shown on the left-hand side and the right-hand side here, where you have different projects with different magnitudes and also in different stages of development. And also you have products within your portfolio that are working off of each other to maximize reuse, and you can also see that there's a profit curve that's driven from this. Another important step in the R&D process is to verify that a technology has gone through the necessary checkpoints and is mature enough to be integrated into the new products. It's also important to get the early resources familiar with the new technologies and also bring on resources that are familiar with the technology that will be reused. That's what you would do over on this side of the staffing profile. And on the right-hand side, there's a nice process that was outlined by Don Clausing in the innovation reading that we had from one of our lectures. Just like any economy of scale, integration of new technologies will start off costly, but will lead to good profits if they're integrated into products correctly. At some point, the technology will need to be phased out because it is no longer making the product profitable. A good example of this might be like a CD player, where it used to be an extra feature that someone had to purchase in a car. But now it seems like you can probably get a CD player standard in any car that you would buy today. And who knows, maybe they'll even be obsoleted in the future by other features like USB, Bluetooth, and other features that you see in infotainment systems today. So this kind of summarizes the problem space for the optimal reuse of technologies. Now I'm going to start to get into the characteristics needed for modeling this business process, and then I get into my model and some of the references that I was able to look up. When planning for new products, it's important to understand the backlog of potential features and also how they will eventually be implemented into new products. Companies that understand the best way to balance this effort will have the best opportunity to be successful in their respective market. In the innovation reading from this semester, Chester Carlson discussed the importance of understanding how products fit into the global market and also how providing the optimal product mix of new and reused features can lead to success of those products. You can kind of see on the left-hand side how there's an overall business strategy and product vision. This is being put into the product portfolio along with the product architecture. And then also you have effective innovation, which is being driven by the R&D investment. And then those are both being fed into the product portfolio. But in addition to that, you have your product pipeline and you have key technologies that are being reused. And this is kind of what drives the economy of scale of those new technologies. This product platform model is what I initially created to capture the concept of technology development and also how it can be leveraged in new product platforms. This model also included balancing loops from the platform to reuse existing technologies. This is the reuse loop shown here. And also to commonize on the existing technologies as much as possible to drive up the amortization, which is really dollars per unit. This is a big part of the manufacturing investment loop. The introduction of requirements unique to each customer and product represented the reinforcing loop that is present in marketing. In general, engineers always like the latest and greatest technologies, so it was also important to show this balancing loop of introducing new technologies into the new products. In my next slides, I'll show how I'm able to find another set of great examples that were very close, but also allowed me to stay within the original scope. Unfortunately, I wasn't able to find the exact right reference modes in order to verify and validate this model, so I kind of had to move on to a different example. But it wasn't far outside of, or really at all outside of my scope of what I had originally intended. The model shown here comes from another reading we had this semester called Dynamics of Concurrent Software Development. And this model is extremely complicated. My objective here was to recreate a simpler model that would hopefully achieve the similar results. And I knew one consequence of trying to do this may be that I'm sacrificing model robustness. But in order to get into the dynamics of this problem, I wanted to be able to, one, produce a model that was simple enough to be done for this class, and also could kind of fit within the scope of what I was trying to do and trying to study. Within the paper, they also began to simplify the model for their specific studies, so they were kind of doing the same thing that I was doing. This figure shows the reference model I ended up using, and here's my Vensim model that matches that. You can see that there are 3 balancing loops and also 3 reinforcing loops. There's a balancing loop with productivity, which feeds into the feature release. That feeds into an increase in the defect generation, which overall increased the defects in the released code. But that then fed back into the architecture and back into the feature release. So you also see a balancing of reinvestment that goes from the increase in schedule pressure, which would decrease the resources for the capability development, but then an increase or decrease in the resources would be directly proportional with the capability growth, and that would feed directly into the development capability. This represents the investment that the company made back into the people and into their technologies. These are the reference modes I was able to grab from that concurrent software development paper. You can see that they focus on feature release, which is measuring features released to the market per month, and then also development capability, which, like I said, is measuring the investment they made by the company back into the people and back into their technology. Next, I'll go into some of the results I had with my model and then also show how it compared against these reference modes. So to start with, my results were a little bit shaky. As you can see here, compared to the feature release plot from the reading, it's really not even close. And I kind of had the same results for development capability. It was a little bit better, but still not what I was looking for. So from there, it was kind of back to the drawing board, and I had to make a couple of tweaks to my model, and also add some different variables that might be needed in order to try to get some better results. So you can see here that my results still didn't match perfectly, but they were staying in the same magnitude, and they were also starting to show some of the similar behavior. Now, I didn't really have as nice of a I guess a balancing effect on here. I would have liked a nicer curve, but what you see here is that I started off with feature release. I had a spike, not definitely a bigger spike than what they had here, but then it starts to go back down and then eventually approaches 0. That's what they have over here. They had a lot nicer curve though too. And then for development capability, I liked the results, but again, it wasn't as nice of a or as smooth of a curve as what I would have probably preferred or what would have been ideal. And what you can see here is that there's a slight increase from the start, and then it starts to smooth out downward. I really didn't have the right concavity of the curve, but you can see that there was definitely a spike, and then there was kind of a balancing, and then it eventually approached 0, kind of like you see here. So here's my final model. My conclusion on the right-hand side is that the stagnation of the feature release drove the features under development to keep increasing, and this continued to reinforce the schedule pressure, which then increased the defect rate. So some more time, some more assistance on this model, I probably could have gotten a lot closer, but this is what I was able to produce up to this point. Overall, my conclusion is that adoption of new technologies into the products is critical. Investing in R&D should help to minimize system integration effort. Focusing on an optimal new to reuse ratio is key to the success of the product. And also, reuse reinforces cost savings as first time quality increases. Thank you for listening, and also thank you for your time.